So to introduce our last speaker of the day, who is bringing like the very, just a fascinating presentation. We're taking it to the next frontier, and we're taking the conversation into space, because cybersecurity is not only built and necessary for the stability of our technology, our companies, our countries, our societies. It's also important about what we do next as a species and with our technology, which also involves going into space. And there's been a lot of that happening lately. I mean, traffic in space is increasing. So there are plenty of challenges who are new and interesting to address. So I'm very, very privileged and happy to bring you Paul Coggin today to DefCamp 2021 with a presentation called Pwned in Space. Paul, thank you so much for joining us.
I wish we could all be in person again. I miss seeing everyone. Hopefully next year we can, everyone can get back together again. But I appreciate the invitation. My area of interest I want to share with you today is around space. This presentation is going to focus on spacecraft and vulnerabilities and real world examples of exploits that have happened to spacecraft. In the future, I plan on diving into ground systems and the whole system of systems, but this talk we're going to focus on the spacecraft itself, and especially like everything's in the news with all of the new space companies, Space 2.0, et cetera. So I thought it might be of interest to all my friends here. So with spacecraft, once you get the spacecraft, whether it's a space station or a satellite, what have you, into space, it is managed and controlled. Similar to a network operations center, security operations center, you have space operations centers, space ground systems that monitor and manage the spacecraft as it orbits the Earth. It could be in LEO, GEO, which we'll dive into, the different heights of the orbit in space. But to make sure that the spacecraft has coverage and can be controlled and managed no matter where it is in the orbit, especially for LEO. In this example here, we have ground stations located around the world for NASA so that they can
Sorry
monitor.
to interrupt, Paul. Sorry, I'm sorry to jump in, but if you could just share your screen so we can see the presentation as well. Sorry to break your flow there.
Okay, it should have been shared. Let's see. I'll reshare it. You see it now?
Yes, I can see it. And if the tech team can just switch to it so we can have it in full view.
Okay, I just reshared it again. So
we're ready.
So this is an example of a NASA network of ground systems to monitor and manage spacecraft assets that they're managing for this near Earth network project. So that you can have complete coverage, no matter what where a spacecraft is in orbit. You would have ground systems around the world to ensure management and monitoring and control. What's happening with the industry now, especially with what is termed Space 2.0, with SpaceX and other new world space companies that are coming out, all the CubeSats, all those projects, is a move toward ground systems in the cloud. You have companies like Amazon, Microsoft. They have they're offering satellite ground system services in the cloud. My understanding is Google is going to provide cloud-based ground system support to SpaceX, and I believe I've read that Google is looking at expanding and offering services possibly similar to what Amazon and Microsoft is doing. And there are some other vendors that also provide a cloud-based space ground system solution, so that organizations don't have to go and build a diverse ground system network around the world to drive down their costs, so they can focus on their spacecraft mission. So it's really interesting to see what's happening with space and the cloud. Now, when we talk about spacecraft orbiting in space, a lot of what we read about today is spacecraft CubeSats that are going into a LEO orbit, a low Earth orbit, and they're about 160 kilometers to 2,000 kilometers orbiting the Earth. And then you have the high Earth orbit, where there's 16,000 to 133,000 kilometers in space. And then you have medium Earth orbit, 2,000 to roughly 36,000. And then you have GEO, which is around 36, close to 36,000 kilometers, maybe greater. And the GEO, it is going to be orbiting at a fixed point on the Earth. The GEO will always be pointing at the same place all the time, where the LEO is orbiting the Earth very quickly. So you may have coverage for a few hours on a particular LEO satellite. And that's where they're coming up with ideas of how to network LEO satellites together so that you have continuous coverage as the LEO sats orbit the Earth. Now, we're here to talk about cybersecurity. And so the Federation of American Scientists have come up with 5 categories of threats to spacecraft. There's deception, where someone can influence the spacecraft to send incorrect information. Maybe a threat actor temporarily disrupts or denies a capability on the satellite. And with the disruption denial, maybe it's a electronic warfare, some kind of radio frequency jamming, some kind of RF attack, where the attack occurs and then it goes away. They turn, the power is removed, the RF signal is removed, and then the spacecraft is able to operate like it normally would. And then there's degradation, where permanent damage is done to the spacecraft. Could be, say, maybe it could be a laser that damages a part of the spacecraft, or some other kinetic type attack possibly. And then there's the destruction. Like we read about, a lot of countries are testing ASAT capabilities, where they're actually blowing spacecraft up to test the ability for a missile to hit a spacecraft. So that would just totally take it out. So that's some examples of threats. To get into more detail regarding space systems and cyber threats, you have jamming, which is focused, like I mentioned, on like electronic warfare, radio frequency jamming, which is going to require a great deal of power and an antenna that has the ability to send a very strong signal and overcome the good signals of the satellite. Malware, I've got an example of malware, a couple examples of malware on spacecraft. Spoofing the control payload. So the satellite, it has the control system for the satellite that flies the satellite itself, and then there's the payload portion of the satellite. And the payload is going to have maybe tied into one network, and then there's a different network that is controlling and flying the satellite itself. So the payload may be targeted, where the experiments and scientific discovery, whatever application it is that the satellite is providing in that payload, that could be targeted. And then you have the control, telemetry, tracking, and control. And that's where the satellite is being flown, the TT&C, that could be targeted specifically. And if there's not encryption being used, and there's a great deal of the satellites that are flying today that are not using encryption because of the cost. It costs a great deal of money to add really strong encryption to the satellites. So in many cases, there's not encryption being used. So it could make some of the satellites could be vulnerable to replay attacks that we're familiar with in land-based attacks. Of course, you could hack it. Typically, the hacking is probably going to be through a ground system first. Someone is most likely would, the trust relationship of a ground system would be exploited first, and then from the ground system, then the satellite would be targeted in most cases. And then you could possibly do some hijacking and eavesdropping. Again, going back to a lack of encryption. There's been a lot of presentations at Black Hat over the last couple of years talking about being able to eavesdrop on network connections, satellite connections, and because of a lack of encryption. And we're going to go into some real world examples of that as well in the next few slides. So we talked about threats. And one thing with the spacecraft threats, if it's like electronic warfare, some kind of RF radio frequency jamming, those type of attacks are reversible. You deny the service while you're sending a very strong signal. It's being generated, directed at the satellite. But as soon as that is turned off, it goes away, and the spacecraft can go back to operating as normal. But you start to say connects that would physically damage the satellite, like shooting a missile or maybe a laser or something like that, then that is not going to be reversible. But depending on the cyber attack, what kind of access an actor has to a satellite, they might be able to do something that's non-reversible, just like you would do to a data center asset in a LAN, because it's a computer. But depending on the level of control someone has, they might be able to go and do permanent damage to the satellite. So the open theoretical attack strategy, looking, say if you're going to look at the risk to your spacecraft systems, if anyone is looking at securing a new satellite venture that they're a part of, wanting to secure those assets, here's an attack tree to just some ideas to think about. You have the ground station that you need to secure. You got to make sure that you mitigate the insider threats with not only the digital access, but also physical, because there's always an insider threat, as we all will know. And use air gaps and one-way diodes, et cetera, to limit access into the ground system network that's controlling the spacecraft. I personally prefer a hard air gap, but as we move toward cloud, that means these cloud-based ground systems are going to be connected to the internet so that you can remotely access your cloud resource, say it's Amazon, Google. So we're going to need to really lock down that remote access into that ground system. And then very theoretical, there's nothing been published that I've been able to find in the open source about a satellite to satellite attack, but it is theoretical that, especially with all the advances happening with onboard computers, the computer capability. I actually read the other day where there's a company looking at putting a 19-inch rack server in a satellite and being able to run like micro data centers in space. So those capabilities, satellites are getting more and more sophisticated. So it could be that at some point we could have a threat of a satellite to satellite cyber attack. Where a satellite is doing RF attacks or optical attacks, trying to get into the network, possibly. And then there's also the threat if a threat actor has the resources, they might be able to throw up a unauthorized ground station. And if the satellite is not using strong encryption, it could be possible for a threat actor using an unauthorized ground station to possibly influence the spacecraft, maybe possibly gain control and access, either gain access to the control system on the satellite or possibly the payload, depending on their capabilities. Here's one reference that they really caught my attention. It was years ago. Everybody was talking about Stuxnet, but it's not. I never saw a whole lot of conversation about this event, where around the same time that Stuxnet came out, a satellite that was providing cable TV services in India called INSAT 4B was said to have been targeted by Stuxnet. So going back to that trust relationship we talked about earlier with the ground system, somehow Stuxnet, either through someone bringing in a thumb drive or some other kind of media or some kind of internet connection, somehow that trust relationship with the ground system to the satellite got breached, and the Stuxnet malware was introduced into the ground system network, most likely, and through that trust relationship was able to spread and find its way onto the INSAT 4B satellite. And it is said that the INSAT 4B satellite was running the same Siemens PLC, programmable logical controller, that the original target for the malware was running. And what was happening with that PLC is it was used to control the solar panels on the satellite. So it ended up disabling the solar panels, it is speculated, and thus killing the satellite. So there's an example. Now, there's a lot of arguments about whether it happened or not, but there's a whole lot of coincidence. It lined up really closely that strongly insinuates that this is what happened to the INSAT 4B satellite. And I'll provide a reference there. And satellites do use programmable logical controllers in some cases. A lot of the same systems that are used in critical infrastructure are used on satellites. Now, I mentioned early in the presentation about some of the satellites are not using encryption. And one of the reasons they're not using encryption, what's driving the expense is radiation. In space, there's what you call space weather. It's and with radiation and solar flares coming from the sun, and there's all these microscopic particles that can inject themselves, can negatively affect computers running on the satellites. And if you were running encryption on a satellite and there's like some kind of solar storm, etc., it could go and negatively affect a processor. And if you're trying to do encryption, it could mess up the keying of the encryption, and you could possibly lose control of your satellite because of a solar storm. And so what you have to do is you have to use equipment that has been protected for the harsh environment of space with all the radiation issues. And that drives up the cost. That radiation protection just drives up the cost of using strong encryption. And so therefore, a lot of companies choose, because of business economics, choose to not use encryption and try to use other means to protect their satellite from hackers. But as we all know, being cybersecurity professionals, if it's not encrypted, someone is probably going to find a way to try to sniff it, analyze your traffic, and see what's going on with it. And so we'll go into some examples here. One example of a lack of encryption on satellites, this is real world, and I provided the source reference there at the bottom, is a few years ago, there was a satellite that was used for communications that was discovered that there was people in Brazil, and apparently 39 people in 6 Brazilian states got arrested for illegally using a satellite for CB radio communications. And it was possible because it was unencrypted. So when you read out in the papers, everybody talks about encryption with space. Some things are encrypted. Some things that are very sensitive are encrypted. But there's a reason why people are able to hijack cable TV signals, internet, etc. Because a lot of places it's not encrypted because, like I said, the expense of putting radiation-resistant hardware in space to protect the crypto. And here's an example of internet. There's a piece of malware that was developed that Kaspersky speculates was sourced out of Russia. And in this case, a user would get infected and used their satellite internet connection to establish the command control. And once command control was established over the through the satellite connection, the satellite internet, because it's all unencrypted, the threat actors, the malware server, and the users were all able to communicate. There was no problem communicating because it's unencrypted communications. And once the command control, the initial connection was set up, then the connection would reroute over a terrestrial land-based network to exfil data, whatever the malware's purpose was. So this is a real-world example of unencrypted communications being exploited. Another example of unencrypted communications is that you may be aware of was drones, the unmanned aerial vehicle. In this case, there was video communication, actually GPS communication, timing that was affected because of a lack of encryption. Now, here, this goes back to what I talked about in the attack tree. This is a theoretical attack. There's nothing in the open source that I've been able to find, but there is some open source speculation about this being a possibility. I've seen in a few papers of the satellite to satellite attack. So it could be that as the technology evolves rapidly the way it is, it could be that a rogue satellite could possibly be in orbit in LEO or GEO and possibly do some kind of man-in-the-middle attack and possibly try to intercept RF communications between satellites, or possibly try to get in between an optical free space optics connection. That's a big hot topic right now, is free space optics. Is being able to use optical technology, use light, which is a whole lot more secure than RF, where RF radio frequency is just being radiated and is more open to other people being able to listen and capture the traffic. With the optical, it's going to be, obviously, it's going to be a laser. It's going to be more directed. And so it's going to be hard, optical is going to be harder to intercept. But this is a theoretical scenario that it'll be interesting to see what happens in the future. What gets published about this is as the spacecraft technology evolves. Now, here's a real world example of a satellite called ROSAT that is speculated to have been captured. There's argument back and forth. I've read online about whether it was actually hacked, but everything I've read is pointing toward that the satellite was hacked. Most likely, the ground system was first hacked, and then from the ground system, the satellite was taken control of, or someone had a rogue. They had possibly had a rogue ground system that they were able to use to take control of ROSAT if it wasn't using strong encryption, and it was able to be control was taken, and it was able to be turned toward the sun, and it was able to damage the capability of the satellite. Now here's an example. This Landsat 7, I have two examples here of this attack, two different satellites. There was Landsat 7, where it was taken control of for 12 minutes back in October 2007 and July 2008. Whoever the threat actor was had all of the access they needed to control the satellite. They did not do anything to the satellite, but they had access. The forensics that was done, it was determined that whoever the actor was had complete control of the access, and they could, if they knew what they were doing, they could have took control of the satellite. Now, I'm going to do a presentation in the future. Hopefully I'll get to return to DefCamp and present on this, where I'm going to present about all the numerous operating systems and the numerous languages that are used to control a satellite. I think, and so it might have been that they got the initial access, but they may not have been familiar with the commands for the particular operating system and that was used on the satellite, and maybe that obscurity lent to them not being able to fly the satellite themselves, and they just had the initial handhold. Similarly, a very similar attack around the same time frame was the Terra satellite, and it was attacked in June 2008 and October 2008, and the threat actors had control for 2 minutes on the first attack and then 9 minutes for the second attack. And similarly, they had the access, but they did not take complete control of the satellite to fly it. And again, I'm wondering and speculating whether they knew the operating system, the commands to control the satellite. It's interesting that they did not go and influence how the satellite was flying and influence its orbit or something like that. And then here's another real world attack that happened. It's published out in the open source, where there is a U.S. weather satellite that was taken control of. This is one I found very interesting. There was a satellite network that was comprised of 4 satellites owned by the UK. And my understanding is these were Skynet. It's 4 satellites, and they're military satellites. And my understanding is that one of the satellites was actually taken control of and held for ransom, which is really interesting. And which leads into, I don't have any slides on this, but an interesting thread to pull with all of the new satellites that are being put up in space, and they're running like Linux operating systems, all the different. It's moving more and more toward open source for the satellites that are being launched today, all the CubeSats. We're hearing about all the thousands and thousands of satellites that the internet providers are going to launch into space. Wouldn't it'd be really interesting what the threat surface is for ransom? Speaking of a satellite being taken ransom of, ransomware hitting a spacecraft and some kind of worm that propagates across space. How would we deal with that? I mean, it's theoretically possible. Another real world attack you might not be familiar with. This happened on the space station. It's not a satellite to take it, but I just wanted to be complete in my research of what I could find out in the open source spacecraft. So with space station, it's certainly a spacecraft. And what happened here is astronauts unintentionally, just like what happens on the ground, somebody brings in a thumb drive, sticks in a thumb drive on the space station, and it has malware on the thumb drive. Go figure, and infects the network on the space station. It did not infect the control system that flies the space station, but there was a network that the malware was able to spread to, and so they had to go in and clean it up. And then there was a second event where a laptop got brought in with a piece of malware on it, and it was able to spread across the network. I found that very interesting. Luckily, it did not. Luckily, the flight control network is isolated from the networks that got infected. But I wanted to be complete and show there's lots of things happening in space that need to be dealt with and mitigated and planned for, just like we have on any critical infrastructure on the ground. Now, if you're interested in diving into security solutions for space, maybe you're working for a startup or some other space agency, this is The Consultative Committee for Space Data Systems is an international organization. Numerous countries are a part of the CCSDS, and they not only have security documents of best practices of how to secure the space protocols, the operating systems, the commands, the ground systems, the spacecraft, but they also provide standards and best practices for developing various protocols, how to build the ground systems, the spacecraft architecture. But they do address security, and they have really good documentation and recommendations on cryptography, how to lock down the trust relationships within the ground system, between the ground system and the spacecraft, et cetera. So if you're interested in this and you want to go and look at some really good references, check out the CCSDS website. It's out. They have a ton of information out there that's publicly available if you're interested in further research. And similarly, here's a pretty good list of what I found available for best practices for securing satellites and spacecraft. MITRE, they have a document for best practices for small satellites. NIST, I'm sure everyone has heard of the NIST organization. They publish a lot of standards that international organizations follow. They've got a new document that they're working on called number 8270. It's an introduction to cybersecurity for commercial satellite operations. This document is draft right now. The last time I looked, it's still in draft, and the number is 8270. If you're interested, just look up NIST 8270, and that is going to be a really good document resource if you're involved with space or interested in doing some research on that of how to defend your spacecraft. And then there's the Committee on National Security Systems, CNSS. They have a number of documents available. Aerospace Corporation, they have a number of best practices for securing spacecraft. And there's also the Orbital Security Alliance. They have some good guidelines for space system cybersecurity. There's a gentleman that's a part of Orbital Security Alliance I recommend that you follow. His name's Dr. Greg Falco. And Dr. Greg Falco publishes a lot of really good quality papers. And he's a part of the Orbital Security Alliance. If you want some more details on that. Now, some of my recommendations is if you're involved with the space industry, whether it's on the ground system or you're involved with the whole system of systems, with the spacecraft and the ground system, is to utilize DevSecOps, and in the initial design and development, design security in from the very beginning, and doing good code review and implementing best practices in the operation and configuration of the network. And the weakest link in the chain is going to open up the vulnerability, as we all know, in that supply chain, whether it's the chips, the operating system, the application vendors, the cloud system vendors, whoever we use, need to really keep an eye on that supply chain, and design the architecture with zero trust, defense in depth, and lock down those communications and the processes in these systems from the very beginning. It's going to be easier to lock it down in the lab and prove out a good template solution that works before we get a spacecraft in space, and we're not going to be able to start redesigning the network once we get it up in space. It's going to be hard to make changes. Again, going back to encryption, really need to try to get encryption on these communication links, because if it's not encrypted, if it's sensitive information, someone's going to be able to passively sit out there and monitor it. And it might be able to go and do replay attacks. It may be able to try to take control of the satellite by doing replay attacks, injection, etc. one of the things that I found very interesting in the research that may surprise some of you is, as I mentioned earlier, that the satellites are moving toward. There's one vendor that's actually talking about, I believe it's Leo Cloud. I believe is the one Leo Cloud is. I believe they're talking about putting a 19-inch server into a satellite, and the servers are running operating systems, and a lot of them are the new ones are running a Linux derivative. So there's a lot of talk about using logging, intrusion prevention systems, machine learning and artificial intelligence. That's actually machine learning and artificial intelligence is actually going to be a payload application that is operated in space and provided as a service to customers. But we should also look at the machine learning and artificial intelligence to monitor the satellite if we have the resources for security purposes, to monitor that telemetry, network telemetry data, and monitor commands and traffic to make sure that the trust relationships are not being exploited, and that maybe an insider is not trying to send commands that are not authorized or out of the norm. And again, monitor that telemetry tracking and control. Monitor that very closely to make sure someone is not trying to send commands to fly the satellite or change the satellite's orbit. Send any type of commands that are not typical, not scheduled, not recognized. Try to keep not only monitor that on the ground, but also monitor it on the spacecraft itself. And use strict system configuration management. And where things are headed with this system configuration management, and you might find interesting, is that just like we're virtualizing the data centers on the ground, virtualization is happening on the satellites. There is virtualization. So it's called software-defined satellites, where virtualization is actually being implemented on the satellite, and even containers. Where payload capabilities, where the experiments, the research that scientists, different organizations may be using on the satellite, say image processing, whatever application it is, the system's being used for. They're actually research not only virtual machines but also containers. So that opens up a lot of interesting possibilities for from a security standpoint. But that's pretty much what I have to share with the team today. I hope this was informative and interesting to everyone. I have a whole lot more research that I'm doing that I'm hoping to bring back and share with everyone in the future. Hopefully, like I said, hopefully we'll get to meet in person soon, maybe next year. Romania is one of my favorite countries. I love Bucharest. I recommend everybody to go visit Bucharest. Romania is a beautiful country.
Oh, thank you so much. This has been not just interesting, it has been mind-blowing altogether. I mean, I can't even begin to say how incredible your presentation was, not just because you showed us how many things might happen, but how many things have already happened that many of us, if not all of us, weren't aware of. I mean, this is an entirely kind of new universe of possibilities, both for defenders and unfortunately for malicious actors as well. So there's a lot of possibility. And this is something that I love about this industry, is that it gives you the opportunity to contribute to something meaningful and impactful in the realist sense. So thank you for giving us, so many examples, and for kind of opening up this entire new field that we can explore and hopefully understand better, because it's already happening. And as usual, technology is sometimes, a lot more fast-paced than security can keep up with. But it's people like you who inspire others and who guide them towards making that impactful and meaningful contribution. So thank you so much, Paul, once again. And I hope we get to see you live as soon as possible, and that we get to meet in person and have you at DefCamp again.
Yeah, and I provided the slides to DefCamp, and so the slides are available if you're interested, and I'm always personally available. You can hit me on Twitter. You can hit me on LinkedIn. I love to talk and share, and I can provide many, many additional resources if interested in the topic. I'm always happy to share.
We appreciate your generosity so much, and I can't wait to actually rewatch your presentation as soon as it's live on YouTube again, and share it with both my friends in the industry and outside of it, because it is just such a fascinating topic that I bet it can inspire others to make their contribution to cybersecurity, even if they're not in the field, which we're all striving to do, because we need so much talent and so much diversity to see all of these angles. So thanks again, Paul.
Appreciate it. Thank you. I appreciate everyone viewing the presentation, and thank you so much for the invitation.
Our pleasure to have you.